Okay, I'm back. And so in our previous segments, we were talking about the planets Jupiter, Saturn, Uranus, Neptune, Pluto, other trans-Neptunian planets. And now we want to talk about some of the moons that are in orbit around these planets. So I wanted you to know about Io, and Io is the first moon of Jupiter. And that's important because that's going to explain properties of Io. So Io is the most volcanic object in the solar system. It has the most number of volcanoes, and it is the most geologically active of any object in the solar system. Now that is unusual because Io is actually about the same size as our moon, and we know that the moon is geologically dead. So how is it possible that something the same size as our moon, meaning that it was so small, our moon was so small that it cooled off rapidly and it lost any of its internal heat, so it's geologically dead. So Io should be the same way, but it's not. And so we think that the heat source for Io is going to be the gravity of Jupiter. So if you recall tidal forces, so that if you've got a planet and a moon, then the planet is going to exert tidal forces. Its gravity is going to exert forces on that moon. And it's going to cause that moon to stretch. It's going to cause that moon to have a tide. And as it goes around the planet, that moon, since it's in an elliptical orbit, is going to experience sometimes more tides and sometimes less tides. So that means it's going to be constantly being flexed, and so it's going to get hot. So you can try this with an old credit card, something that you don't mind destroying. But if you take an old credit card and you begin to bend it like this, then in the middle, if you feel that with your finger, it's going to start to get warm. So as you're constantly flexing something, it's going to start to generate heat. So the moon Io is constantly being stretched because of the tidal forces of Jupiter, its gravity, and that's what's heating it up to the point at which it's so volcanic. Okay, now let's go to our next moon, which is going to be Europa. Now notice that it also is a moon of Jupiter. It's the next one out. So what's unusual about Europa is that it has ice on its surface to a depth of 10 kilometers, and it is composed of water. Okay, then it has underneath that about 100 kilometers of liquid water. And then underneath that is the actual surface of Europa, the rocky part of Europa. So they think that maybe life could exist on Europa. So they have suggested sending a probe to Europa that would have a drill, and then that drill would drill down through the solid water crust of Europa, and then it would deposit a little submarine into its liquid water ocean, which would then swim around looking for signs of life. So anytime that you've got liquid water, there's going to be the possibility of having life. Now, we don't expect the life on Europa to be that complex. So certainly bacteria, but I would not expect anything more impressive than like jellyfish or worms or something like that. Okay, now let's go to a third moon. Now this is the moon Triton, which is actually a moon of Saturn. So some interesting things about Triton is that it has a surface temperature of negative 235 degrees Celsius. It has an atmosphere. So this is a relatively large moon, and the surface pressure on this moon is 1.45 atmospheres, which is greater than Earth's atmosphere. So Earth's atmosphere would be 1 atmosphere, and this is 1.45. So it has a dense atmosphere, but what's it composed of? 90% nitrogen with about 9% argon with some methane. So those are the major components of its atmosphere. So nothing that you would certainly be able to breathe. And also it'd be very, very cold. But the surface pressure, you might be able to survive on the surface of Titan without a pressure suit. Okay, now what's interesting is it has a hydrological cycle, just like the Earth. So on Earth's hydrological cycle is based on water. So that water comes out of the volcanoes, it then goes into the sky, it forms clouds, it then turns into a liquid, it then rains onto the surface of the Earth, it then evaporates or goes back inside the Earth through a subduction zone, and it comes back out through volcanoes. So you have this hydrological cycle based on water on Earth, but on Titan it's going to be based on methane. So if you can imagine, Titan has oceans composed of liquid methane. Now normally when you think of methane, you think of a gas. But if you were to lower the temperature enough, it would actually turn into a liquid. So during the daytime, it's just at the right temperature at which this liquid methane can turn back into a gas, goes up into the sky, makes clouds of methane, and then it rains methane back onto the surface of Titan. And if you look at that picture right next to the picture of Titan, that's the actual surface of Titan taken by a probe that we sent there. And do you notice anything unusual about those rocks? Do you see that those rocks are not angular, they're rounded? So what rounds rocks here on Earth? If you go to a river and you look at the rocks, they're rounded because of the force of water. Well, in the case of Titan, it's going to be the force of methane. Liquid methane has caused those rocks to become rounded. So there's a little video that I'd like for you to watch there called Flyby of Titan, which will show some of this to you. And then also notice that I mentioned life, because there is a possibility that if you've got some kind of a liquid for chemical reactions to take place in, perhaps you could have life. But it's not a kind of life that we would be familiar with, because all of the chemical reactions that take place in our bodies are based on water, whereas on this object it would be based on methane. So we don't really understand how life would exist on this moon. Okay, lastly, we would like to talk about the moon Triton. And Triton is a moon of the planet Neptune. What's interesting is it orbits backwards. So all of the other the planets in our solar system, they orbit counterclockwise around the sun, and then the moons in orbit around those planets are also going counterclockwise. But in the case of Triton, it orbits clockwise around Neptune. And so this is an indicator that Triton was a kind of like a rogue moon that got captured by the gravity of Neptune. So scientists think that Triton originally had a partner, so that there were two moons that were in orbit around each other. But when this pair came close to Neptune during its formation, Neptune's gravity flung the partner away, leaving Triton in this reversed orbit. around Neptune. So there's a little video there that you can watch, and some scientists have speculated that the partner that got flung away was actually Pluto, but we don't really have any proof of that. Okay, in our next segment, we're going to talk about the rings of Saturn. So I'll see you in just a few moments.